for the people who listen to this as a podcast in podcast form, like audio form only, which is quite a lot of people actually. I've not been looking at the stats, but it's far more than you'd expect. Right, we're live. Good. Okay. Hello, everyone. We have Garry Keenor is here, and I'm here. Hello. It's an interesting rail natter because of what's happened today. Clearly, in fact, let's get Garry up properly so you can say hello properly. Garry's here. It's an interesting one in terms of pitching tone because today's been just an absolutely heartbreaking day for both of us. We're really passionate about rail travel and passionate about safety being, well, safety is just number one. Like, a lot of people say it and perhaps they're a bit of lip service, but the reality is I think for most people on the railway we really do understand that when you're moving people around in trains, safety is the number one thing. So it's pretty upsetting for everyone involved, not least the people who are actually involved in the instant emergency services and the staff and passengers involved and their families and friends. So thoughts go out to them really, and we're not. We'll talk about this. We'll talk about it very briefly after we've sort of introduced. But so it's a bit of a somber one, but I think it's important that we continue to focus on the long term and what the railways, the direction the railways are going, and climate change and decarbonisation, which is why we've got Garry joining us to talk about electrification. I'm going to make sure that everything's running smoothly, which it appears to be. There's chat. There are people here. It's important. People are pointing out in the chat that it doesn't undermine the tragedy of today, but rail remains the safest way to move around on land, like by a long shot. And occasionally you'll see people screaming about safety in railways and trying to make a bigger, basically trying to hijack the importance of us learning from these sorts of incidents and make a bigger and make something different of it.
There's three things that are really important. One is that we look after the people who are involved. That's the focus right now, which is why other things can wait. The second thing is to learn what happened and why it happened, and to learn from that and to use that to improve safety on rail, because that's what we've always done. And the third thing is not to speculate about what the causes are until the people who are actually qualified to determine that have done their investigation. And I really can't stress that last point enough. Speculation isn't just unhelpful; it's actively harmful. So it's not a good day.
Yeah, not a good day. But we're gonna have rail natter. We're pleased that we've got lots of people joining us. We've got 60 of you joining us, which is good. And so I think we'll just get started. To be honest, we shall run the intro credits. I think essentially. Welcome to this week's rail natter. The Intercity 225 fades out. I'll bring Garry back. In fact, let's bring the title card back so we know what's going on, so people know what's actually happening. Here we are. We're small in the corner. We're going to talk. So the theme for tonight's rail natter is making electrification stick. That's the theme. That's what we're going to be talking about. Garry's here. Garry's generally pretty candid. There are a few areas that you have to be careful about because of things are actually happening.
Absolutely.
But there's a huge loud
I'll jump in and give the standard caveat, which is that anything I say on this will be my views and my views alone, not the views of my employer. I'm speaking for me and nobody else tonight. So
I never seem to give that caveat at the start of my videos. I really should, shouldn't I?
I think you should.
Yeah, I never do. Arcadists generally don't get too angry at me, but that's because I never mention them. So there we are. Okay. So the first slide is we can't ignore it. Today has been a real tragedy it's just been a tragic day. It's not a day for speculation. So we're, as Garry's said, don't ask any questions about it in the chat because we're just not going to pay attention to them. It's the time now not to be kind of speculating. It's the time to just let the let the emergency services finish what they're doing and then let the investigators come in and do what they need to do. So we're not going to be talking about that. I could talk about earthworks, but actually I'm not going to, because I don't. Having looked at some of the aerial images, it's not even clear. The public information isn't even. It's not confirmed that there was a landslide that caused it. So I'm not going to talk about that anymore. So just thoughts with everyone involved, really. So let's get to the subject at hand, which is wires, and those wires that just kind of float around on top of the railway and make things go. It would be nice if electrification was like, I'll ask, there's probably a blessing in disguise, or rather like lots of problems when this was wired, right? Because overhead clearance isn't an issue, right? But there's not much space to put stuff. You need to have space to put stuff.
It's interesting you picked that phone. I'm assuming this is somewhere on Northwest Electrification.
Yeah, this is the approaches to Lime Street, actually.
Oh, okay, right. Yes, of course they did the remodelling.
So some of it was originally electrified, but they've actually almost re-electrified the whole lot, actually.
This is the sort of environment that does keep the people who do my job awake at night, because it's, you're trying to superimpose electrification on an old, one of the earliest railways in the UK, all sorts of interesting geological and man-made structures there. But that's why we do what we do. There's a solution to most of these problems, but it's as always, having that understanding of what's there already is the key to that. But yeah, I'm glad that wasn't my job.
Yeah, it's quite. I love this picture because it just combines all sorts of things that are tricky and all sorts of mischief. Nice P-way though. Let's go back side by side. So for people who are watching this, not everyone necessarily knows who you are, Garry. So I don't know if you want to just do a quick introduction.
Yeah, sure. So I'm an electrification engineer. I've worked in electrification my whole career. I joined British Rail as a graduate, and I've worked in electrification in some form or other ever since. At the moment, I work for Atkins, and as part of that, I get involved in lots of things, everything from small schemes, small bits of work, very large bits of work, most recently Great Western, but also get involved in things like developing different ways of working, digital tools, digital techniques for measurement. I seem to have, without really planning on doing it over the last couple of years, I seem to have fallen into a sort of measurement and monitoring kind of series of contracts that we've won to do with measuring and monitoring OLE and trying to solve particularly difficult overhead line problems that the standard equipment won't necessarily solve. So yeah, that's what I do, and I work with a great group of people. It's not just me. I know I tend to be the most one of the more visible people within my bit of the industry, but that's just because I'm a loudmouth. That's not doesn't mean I'm certainly not by no means the best engineer in our trade. I work with several people who could show me a thing or two, and that's what I do. I design electrification, advise people on electrification. So that's my job.
And so these, I mean, Garry, you've watched Rail Narratives, you know what the format is. I've seen you ping up and ask questions, so you know the deal. So already I've got a question I think it's quite an interesting one to start with because it's probably an easy one for you to answer. Tom Campion asks, what are the electrification demands of something like High Speed 2, so a new line, compared to something like the Great Western Electrification programme?
That's a very good question. Thank you, Tom. Good question. I can't quantify it because, as I constantly remind people, any electrical knowledge that I appear to have is not as strong as my mechanical knowledge. What I will say is you're going give or take.
I think the context of the question is more like how complex is electrification?
Oh, I see.
I think
it's a strange one because it actually gets easier. A lot of sometimes my colleagues get their heads turned by things like High Speed 2 and say, I'm going to go work on High Speed 2, and I say,
I bet it's really boring.
Why would you want to do that? It's just it's from a systems point of view. Once you've defined the system, once you've defined the overhead line system that you want to use, and made sure that can perform at the speeds and the electrical currents that you want to, it actually just becomes rolling out mile after mile after mile of it. There's none of it's much more, that picture that you put up at the start is perfect. You're not going to get complex situations like that on High Speed 2. There's one exception to that, and that is at the tie-ins with the classic network. So if you want to do something interesting on HS2, you actually want to be on the fringes rather than on the core routes.
Which HS2 have cleverly put a lot of work onto Network Rail to do. I was on one of those interfaces at Handsacre,
and I'm
and it was a
guessing
nightmare.
that's probably because they know that Network Rail are probably the best place people to do that for that exact reason.
Yeah.
And I've done I did some work on High Speed 1 a long time ago. I was involved in one of the contracts that cleared all the existing railway out of the way at Dagenham and Ripple Lane to make way for High Speed 1. And that was really complicated, and trying to keep Ford, Dagenham Ford were using all the sidings, and they were like, we want 24/7, do not disconnect our sidings for even 10 minutes. And that's really interesting. But once all that enabling works is done, the actual systems build, I mean, it's different. If you're on the electrical side, I think it's more interesting, feeding the power, getting the power to the railway. I think that's quite interesting and challenging. But the actual overhead line itself is well, I mean, HS2 have already licensed the French system, so they've quite wisely just said, we're going to use that because we know it works.
Yeah, it's been tested in anger at the fastest speed that steel on steel has gone. I was interested in your other answer, I suppose, but I suppose it's kind of a fairly simple power equation, right? In that if you've got trains that have a pretty high hotel draw and are going really fast, they're drawing a lot of energy, so you need to... I suppose that's from an actual.
It's going to increase the size. I guess it would increase the size of your bulk supply points. Also, getting the challenge with HV supplies is always you've got the railway here, running say there, and then your nearest, available 400 kV or whatever level you want is over here. And how do you get the power to where it's needed by the railway? And you sometimes you even see railways steered towards where the power is, or things like that. So that's the biggest challenge. I think once you've got the power to the line side, it becomes fairly straightforward. But the electrical architecture, I think, will be quite interesting, especially things like the fault protection, and when you detect a fault, how long do you switch it out for? How do you reclose? How do you know where the fault is? How do you isolate the fault but keep the rest of the railway running? These are
given
quite
it's
complicated.
a very intensive service running. Like it's not like a lot of the it's not
like Crossrail at 300 kph.
Yeah, exactly.
Isn't it?
Yeah. It's a metro system that's running at 360 when it's playing catch up. So good question. Thanks Tom. That was great. There are quite a few other queries. Oh right. So okay, I'm going to answer this one because it avoids Garry having to give a long-winded answer. The Game Masters asked, what is the current cost per mile of electrifying a railway line in the UK? 1.6 million if it's an easy one, and thinking that it's about £1 million a single track kilometre, and then maybe 1.5 million a single track kilometre if it gets a bit more fiddly, or maybe 2 million per single track kilometre if it gets really fiddly.
The answer is, and I appreciate that's a kind of that will be a point value within a range. The answer is it's complicated. First of all, the first thing you've got to define is what do you mean by the cost of electrification. So if you think about things that typically have to happen on, if we take a railway that's not electrified now and then electrify it, things that typically have to happen is route clearance. Bridges have to be cleared. A number of things have to happen to some overbridges. Signalling immunisation. You may not have a signalling system that's currently immune to AC interference, in which case you've got to do something about that before you electrify. You may then bring another element. So other infrastructure may need to be upgraded to be compatible with electrification. So do you include that in the electrification costs? So let's take a signalling scheme. If you're going to re-signal this railway in 2025 and you pull it forward in order to get it ready for electrification, should that cost be in electrification or not? So you've got to be really careful, and we've in the past we've got ourselves in trouble because we've not compared apples with apples. And the other thing is that some of those costs probably do need to be included in electrification. So route clearance is a good example of that should be in the cost of electrification because that's why you're doing it. But each route's different. Route clearing a railway that runs through East Anglia, for instance, with very few bridges and lots of level crossings, is probably going to be cheaper than route clearing somewhere in the Pennines.
Unless you kick safety cases into needing loads of new overbridges. But that's another discussion, I suppose.
But then you destroy the case for electrification by
bundling it
in.
Yeah, indeed.
And the business case It's traditionally been very hard to make the business case for electrification because it's been right on a knife edge. The game changer is decarbonisation, and that gives us an overwhelming imperative to decarbonise, and electrification is the only viable answer for many routes.
Which is frustrating because the business case, that for me, that's evidence that traditional business case modelling is broken, because an electric railway is a cheaper railway. It's a cheaper railway. Your trains are lighter, the kit's less complicated, the whole thing is more reliable. You draw passengers in with an electric railway. So yeah, but Garry has to be careful about this, because we can't slag off the current business case system too much, because you're currently in it and harnessing it as best as you can to make that case with using decarbonisation. Anyway, right, let's press on, because we're already 60 minutes in and we haven't moved on, which is what RailNet is all about. So Garry, we're going to just briefly, so you sent me a few slides. We're very briefly going to not do those, because we're going to skip to February 1981. Do you remember February 1981?
I do, yes.
It was 10 years.
Just started secondary school.
Really? It was 10 years before I was born. Let's not dwell on that. But what happened in 1981 was that the Department for Transport and the British Railways Board jointly published their review of mainline electrification, a document which can be found on your Railways Archive site, now up and running again, I'm happy to say. And it's well worth a read. It's very interesting. And they include a map, and they include some not unreasonably optimistic timings. It was 1981, and they were looking forward to the latest date they have is I think 2010 was the last date, which was electrification to Aberdeen. That would be nice, wouldn't it? So I thought I'd just zoom in on the table and just ask you what you think of some of these numbers, and why is it that they're able to? Why is it in 1981 they're giving us these these dates out to 2010? Electrification up to the fringes of the network, if you like, or the fringes of the intercity network by 2010. Why is that happening so early compared to now?
Well, I think the short answer is a lack of and I think it's one of your one of the things that you bang on about is the lack of a long-term plan. The railway has always struggled through lack of long-term planning. British Rail worked on annual budgets, so the way that British Rail was funded meant that it was very hard to look more than 1 year ahead, and it was able to do that by agreeing each and every scheme directly with Treasury, and that was the way that they proceeded. So when you look at the sort of waves of electrification, we've never managed to get to a steady state rolling program of electrification. Ironically, having an early lockdown project that I had in order to help keep my mental health together was to start collating all the stats on what we electrified and when. And what that data shows is that the closest we've ever got to a rolling program was the 1930s. Southern Railway, and unfortunately Adolf Hitler put a stop to that, and that's the last time that we had. Even what people might see the heyday of the 1960s with the West Coast, if you look at it, it's actually very lumpy. In 1960 we're doing very little. By 1965 we're doing an awful lot, and by 1970 we've stopped again, and then we have another big surge in the early 1970s to get up to Glasgow, and then things quieten down again. And then in the 1980s we get the next surge, which is when East Coast was authorised.
Should have got that graph up, really, shouldn't I? It's a great graph. I need to get hold of the raw kilometre numbers off you so that I can do a permanent rail engineering version of the graph.
Yeah.
Because
it's
that
very,
is so
very
spiky.
lumpy.
Yeah.
And that's crucial when you contrast with other countries who have just kind of steadily gone about, electrifying X kilometres a year, and that X hasn't varied by more than plus or minus 20% in any given year. By doing that, you build efficiency. It's the only, I wouldn't say it's the most efficient way to electrify, it's the only efficient way to electrify is to keep doing it, and doing it at a rate that you can control, because then you build skills, you build capacity and capability. The contractors can have some certainty and see, and therefore they have some trust and faith, and therefore they'll invest their money in training and in plants and all of these. Electrification is a production line that starts in the drawing office and ends when the first electric train runs.
Yeah.
And you've got to, like all production lines, if you switch it off for 5 years and then try and switch it back on, guess what? The machinery's rusty, nothing works, and the final product will suffer because of it.
Yeah, and so it's not all doom and gloom. Although, I mean, what's that? Down to Penzance 2003 in the sort of very slow proposal back in 1981. That would have been nice. Anyway, so we're going to skip forward to July 2020, and we're back into your slides again, or rather, certainly these are the official graphics that came from ScotRail. July 2020, and Scotland, having control of its own infrastructure, railway infrastructure, essentially almost totally devolved, not quite, but almost totally devolved. They have done the thing that we should be doing, which is created a map. I mean, it's not a program yet, but it is a map, and there is a plan. And actually, so this map we brought up kind of a couple of weeks ago, but you have, or someone has sent me, whether it was Garry or not, I'm not going to indict him, but there's this extra one, this map here, which I think is more useful. So this is the 2035 one, and you've got these yellow bits, which are...
because 2035 is a staging point. It's not the end state. And I should add that the map on the next slide, that's not a secret. That's in the Scottish decarbonisation strategy. That's their final end state, they think. Yeah. And as with all plans, it's a 30-year plan. Well, it's actually 2020. Yeah, so it's a 25-year plan. Like all 25-year plans, it's going to change, it's going to adapt, it's going to evolve. But as a line in the sand, it's a really strong, sends a really strong signal of intent.
Yeah, and it means industry can kind of get an idea of what it thinks it's going to be doing over the next 25 years, which is just so critical. It is. When I was talking about what I think the structure of the railways should be, I kind of made a point of shoehorning in a slide about transient and sort of contingent labour. And the impacts that has on the industry. It's not healthy for the people who are actually bound by those sorts of contracts, but it's also not good from an industry cost perspective and a doing stuff perspective in terms of rates of completion. So having a plan means that you can actually hire people full time on a proper contract where they know what they're going to be doing. They can actually think about their careers rather than just thinking about the next shift. So this is quite good. So I think it's important to compare these two and show that this 2035 image. And this is really what the rest of the UK should be doing. Is saying this is what we're going to do by this stage. Then this is what we're going to be having. This is the ideal end state, if you like. So that's quite good. I'm glad that's happening, but we have a glaring lack of that for the rest of the UK, really. Right. So
we do it at the moment, but that's simply because the rest of the traction decarbonisation network strategy has not yet been published, but it's getting there. It's getting there. Well, it's exactly.
Drafted, actually, it is drafted and circulating. I think that we'll hopefully see the final version maybe later at the end of this year or maybe early next year. I'm not sure of the exact dates.
And I'm looking forward to seeing an equally strong and bold plan for England and Wales. So.
Absolutely, yeah. So just flick through to see if we've got any questions. Here's one that's sufficiently far in the distant past that you probably can discuss it, which is that Romy Adekrat asks whether the 1955 modernisation plan and abrupt, and I'll add my own addendum, chaotic dieselisation, did that put paid to electrification? Wasn't the original plan to phase steam out much more slowly while electrifying mainlines? Thoughts? Garry, Keenor?
I think the modernisation plan was a double-edged sword is an understatement. Clearly the modernisation plan did trigger some wide-scale electrification, specifically the West Coast, and also Glasgow and Birmingham suburban electrification. So in that respect, it was good. But of course, Gareth, at that point, the regions in BR had all the power, and each region had its own view on what traction strategy should be. Famously, on my patch, on the Western, it was all diesel hydraulics. We not having any of that weird electrification stuff. We want diesel hydraulics, and that didn't go well. And those locomotives were all scrapped, with a few exceptions within 10 years. But I think crucially the way that the modernisation plan was rolled out by BR was pretty disastrous for the industry in terms of cost control. We picked a lot of the wrong technologies. The whole marshalling yard thing, for instance, building marshalling yards for traffic that was already walking out the door,
declining,
and it hugely damaged the railway's reputation with government and the Treasury for decades afterwards. And this is all a matter of public record, and people who are much better at railway history than me have written extensively about this. So I've got mixed feelings about the modernisation plan.
Yeah, it was a shambolic disaster, is my view of the modernisation plan. It was just a catastrophic missed opportunity.
Quite sad that we never got nuclear trains either, which is I'm
all for the French approach to nuclear trains, which is that all of their high-speed trains are nuclear powered.
Yeah.
And it should be the same for us. Anyway, right, okay. So, the next thing we're going to talk about is, unless there are any particular questions on that, there are quite a few queries. Oh, actually, that's quite an interesting question. Right, Gary, I'm going to keep you up because we just had an interesting question that's quite a sideways one, but it is interesting, which is Michael Dono asks, how practical would converting the Tyne and Wear Metro to 25 kV be?
Ooh, that's an interesting question.
Particularly given what we're going to talk about in the next slide.
I suppose the first question, I'll answer, and I'm terrible for doing this. People who know me will tearing their hair out at this point, because I'm going to answer the question I prefer to answer, which is, why would you do that? The main reason why you might, if you were building a metro today, you might choose to electrify it at 25 kV. The reason for doing, there are two reasons to do that. One is that the substation costs are usually lower because you need fewer of them. So substations are not cheap; they're expensive installations. So the fewer of those you can have, the better. And the other answer is famously horrible DC stray current. So once you've built the Tyne and Wear Metro, which you have, and it's quite happily operating at 1500 volt DC, the substation cost issue goes away because you spend that money. The stray current issue is obviously still there, but Tyne and Wear Metro, I'm sure, have got to a point where they know how to manage those stray currents. But in terms of conversion, I imagine it wouldn't be. It's not going to be straightforward, but it would be doable. The things I'd look at first, there's a section from the centre of. I'm not that familiar with Newcastle. In fact, I only went on the Metro for the first time last year. But the tunnels, that's the first place you look. Have you got the clearances in the tunnels? If you haven't got the clearances in the tunnels, I'd stop right there.
Yeah, that's getting on really, isn't it?
If you've got the clearances in the tunnels, then the rest of it's doable, but it would have to be done in a very managed way. And again, the question would be, why are you doing it?
Yeah.
What's the overwhelming reason to do it?
And particularly, the next slides are relevant to this, which is kind of why I picked the question, which is that actually, given the advances we've made in the UK in reducing the requirement for in reducing electrical clearance requirements, that would make taking the Tyne and Wear Metro and turning it into an AC system, it would make that quite a bit easier. Talking of which, I'm going to go back to small faces again, because the next thing we're going to talk about is cost reduction opportunities.
Yeah, sure.
Which we were interested to chat about this. So let's put the picture up. And there's a load of different stuff here. So I'm going to keep this picture up and we can natter away. But actually, there's probably more to talk about than there are in these snaps. Gary, tell us about cost reduction.
Yeah, so obviously, even before the decarbonisation agenda exploded, which it has really only over the last 18 months or so, in terms of rail, even before then, the industry was acutely aware of the need to reduce unit costs for electrification. I won't rehash the story of Control Period 5. Anybody who's got even a passing interest in the railway industry will know that CP5 electrification didn't go well on some schemes. Other schemes quietly delivered, but of course quietly delivering doesn't get the headlines. So the whole industry is really aware that we need to reduce those unit rates. And you mentioned 1.6 million, and that's too expensive. It needs to be lower than that, and over time it will get lower than that, absolutely. And so the industry, led by Network Rail, but supported by the supply chain, is already well on with looking at a number of measures that will that electrification schemes in the decarbonisation plan will be able to take advantage of. And they're all these different ideas and initiatives. They're all They're at various points within the trial process, if you like. Some of them are quite mature and quite advanced, and others are earlier in the pipeline. But all of them show promise, which is really, really exciting. The one on the left it was the cleanest image I could really find of a series of measures that collectively are known as voltage control clearances. So, what are voltage control clearances? So, if you think about a wire, if you think about an overbridge that you need to electrify, you've people like me have essentially got an air gap. We've got an air gap between the roof of the train and the underside of the bridge, and into that air gap, we've got to cram not just the live parts of the system, but an insulating air gap upwards to the bridge and another insulating air gap downwards to the train, because the train is earthed. Flashovers to the train are just as bad as flashovers to the bridge. So we've got that air gap to play with, and there's usually not enough of it. That's the goal. The iron rule of electrifying Victorian railways is there's never enough room through the bridges. So in previous times, we've had to take some painful decisions about either reconstructing a bridge or lowering the track to increase that air gap to give us enough electrical clearance such that a flashover doesn't occur. Now, the interesting thing about that air gap is I won't, Gareth, I'm going on too long. I tend to rabbit. Just shut me up.
That's literally what Rail Natter is, Garry. You're all right.
I know. The air gap isn't there, and this is something a lot of people don't understand. And like, what's he talking about? The air gap isn't there for a 25 kV withstand. So if you think about an air gap, that air is an insulator, and broadly its resistance to electricity is linear. So it's linear with the size of the air gap. So if the air gap doubles, its insulation strength doubles, roughly. So the air gap for 25 kV is significantly smaller than the air gaps that we actually demand in our system. And the reason for that is simple. It's very timely, actually. I've spent most of today anxiously watching a lightning map because I've got a team out on site today measuring overhead line, and obviously at the moment there's a lot of lightning storms popping up. So I've been on lightning watch to alert them to anything that might be coming their way. And these air gaps are for lightning. So what happens is overhead line is incredibly attractive to lightning. In fact, there was damage on the East Coast Main Line today, I believe, due to a lightning strike. It's a very long, thin, exposed earth sticking up into the air, so it's very attractive to lightning. So what happens is the lightning strikes the overhead line. The voltage in the overhead line immediately rises to hundreds of kilovolts. It obviously varies, but 200, 300 kV spike is perfectly normal for lightning. And what that does is it breaks down the air gap. Suddenly that air gap that was an insulator becomes overwhelmed, a flashover occurs, the air is ionized and turns to plasma, and plasma is a brilliant conductor of electricity. And at that point you might think, yeah, but then the lightning dissipates and it's fine. No, because you've just created an earth path for traction current. So the traction current piles into that plasma and goes, I'll have some of that. I can go home now. I can go back to Earth. I can go back to the substation. So traction current starts flowing. And the thing about an arc is it's self-sustaining. Once an arc is struck, it's self-sustaining because it heats the air, ionizes the air, and that air stays ionized. So even once the lightning dissipates, you've still got a flashover. So that's why our air gaps are typically, we're talking about 270 to 370 millimeters is a good air gap to withstand that lightning. So what voltage control clearances does is take lightning and the other thing that can cause problems is intrusion, things intruding into the air gap. Things that can intrude: pigeons, other birds, trampolines, carrier bags, sheds, balloons, you name cassette tapes is the old classic. Kids love used to drop over the a range of objects can find their way into that space. So the two things you've got to somehow deal with if you want to reduce your air gaps are lightning withstand and intrusion from objects. So the lightning withstand is dealt with by this device you see on the left here, which is a very clever bit of electrical equipment called a surge diverter, also known as a surge arrestor. And what it does, we call them, the formal title for it is a non-linear resistor, which, think of it like a tap, right? and under it, you connect it to the overhead line, and you connect one side to the overhead line, the other side to earth, but it's a tap, and ordinarily it's closed, so the valve is closed, so no current can flow from live to earth. So in normal operation, it just sits there. All right. But what happens is inside it's a semiconductor, and as soon as the voltage rises to whatever threshold you want to set it at, it suddenly goes from being closed to being open. So this one is set with a threshold at 75 kV. As soon as the voltage goes above 75 kV, it becomes a conductor. And that suddenly all of that current, whether it's lightning current or indeed traction current, can flow direct to earth. And by flowing direct to earth, the circuit breakers in the substation then detect it as a fault, and they will trip the circuit breaker open and switch off the supply. So the idea is that if you do ever get that sudden rise of voltage, rather than the air gap at the bridge breaking down, all the current flows through this device instead. So it literally diverts all of that energy away from the bridge. The flashover never happens. So by doing that, suddenly you don't need a 200 kV withstand air gap anymore. You need a 25 kV withstand air gap, which can be significantly smaller.
As thick as the paint.
1/10.
Yeah.
But what this doesn't deal with, it doesn't deal with the intrusion of objects. So the other thing that is in the mix for voltage control clearances, as well as the surge diverters, is an insulating paint coating on the bridge, and also an insulating cover on the contact wire and on the bridge arm. So the idea is it's a suite of measures which collectively allow you to reduce the electrical clearances, and this has been trialled. In fact, this photograph was of the trial site in Scotland, which was a very successful trial. But it's actually now in operation. There's one location in the UK where this is in operation at the joint most famous bridge in Britain at the moment, which is Cardiff Intersection Bridge. Obviously, there are a few other bridges like the Forth Bridge and so I talk about those. But Cardiff Intersection Bridge just outside Cardiff has these measures applied, and the electrical clearance after tolerances is about 70 or 80 millimeters. So we've gone from 270 millimeters to 70 millimeters, which it doesn't sound like a lot, but it can be the difference between rebuilding a bridge and not rebuilding a bridge.
And in the
every
case of,
millimeter counts.
Yeah, for anyone who hasn't had the benefit of any of the presentations about Intersection Bridge at Cardiff, there's a canal under it that feeds the whole it feeds a dock that happens to then be used by the fire brigade, so that can't be diverted at all. And there's also, as an intersection bridge, that's two railways intersecting at different levels. You can't then move the railway above it any higher because you then have to bulldoze Queen Street Station, and also I think it ends up pushing S&C into Central Station the other direction.
And it's also the water supply for a steelworks.
Oh yeah, that's
and you can't switch off a steelworks. It's not possible or safe to do so.
So this was an imperative for this. So I think this whole suite is called. AC electrification with DC clearances, I think, is sort of what this whole suite is called, isn't it?
That's the slogan that's being used to kind of, and it's a good, although slogans can be dangerous things sometimes. I think it's very good because it describes in a nutshell what it allows you to do.
Yeah.
And
for people who know what DC clearances are, that is. For everyone else, they're none the wiser.
Static DC clearance of 1500 volt is 100 millimeters, so it is actually it's arguably below. It's below DC clearances, so it's really, and this is going to, so nowhere else got some more tests to conduct because Cardiff Intersection is one kind of bridge, so we need to understand how it performs at masonry bridges and other sorts of bridges. So they're generalising the testing, but we expect to see these measures being routinely used in new electrification schemes, and indeed these measures are already being built into the planning work on future electrification schemes, which is really good.
So we're already miles late, and it's 20 to 8, and I don't know to what extent you can
but there are other
overrun.
things as well.
I was going to say there's more to talk about. Keep going.
So what Neverell are doing at the moment is really looking across their whole portfolio and saying, where are there, because electrification really hasn't refreshed itself in terms of its rules and its ways of working for quite a while. A lot of the rules that we use were really laid down just after the war, around the time of the Modernisation plan, and have been in place ever since. And those rules deliver you a safe, reliable electrification system, but they may not represent the threshold of where performance or safety begins to break down. The actual threshold may be some way beyond where those rules put us. So there's quite a lot of work going on, and there's one specific piece of work that we're involved with and that I'm involved with, which is to measure uplift. So uplift is simply when a train goes through along the overhead line, it pushes on the wire. It has an upward pressure, and that lifts the wire. And when you get to an overbridge, the wire lifts, and we have things called bridge arms to limit the amount of lift, but you don't want zero uplift because it's dynamically that's very bad. So we always have to allow for the wire to rise as the train goes through, and obviously that means the live parts get closer to the bridge. So when we build up our minimum bridge height, we have to allow for that uplift, that upward movement of the wire. But crucially, up to now, we've been using a single value of uplift regardless of speed, regardless of the OLE system we're using, regardless of the pantograph or other variables. But we know, anecdotally, that these variables have an impact on uplift, but we don't know how much. We don't know what the relationships between speed and uplift are. We don't know the relationship between wire tension and uplift. We don't know the relationship between the type of pantograph and the uplift, and there's other factors as well. So what we're doing, we're collaborating with Network Rail, and we are going out and using a really, really clever, exciting digital technique to measure uplift at multiple locations around the UK. So we are going to be measuring at 10 locations around the UK. We've selected those very carefully so that we get lots of different parameters and variables and speeds and types of OLE to actually measure the uplift and see what it actually is in reality. And we're using a technique that we basically use they're not ordinary video cameras, but they're not super high specialist video cameras either. They mount on ordinary survey tripods. We set them up in the CES, and we simply shoot video of the bridge arms and of the wire either side of the bridge as trains go through. What we then do, the clever part, is we then take that video and we then run it through special correlation algorithms, and we are actually able to directly measure uplift to, we think at the moment, around about 3mm accuracy. We're still getting into that because it's the first time we've used this technique to measure uplift, but certainly to a level of accuracy that's better than anybody's been able to do before. And this the image on the right there was the trial that we did, and we put this together very quickly. This is just some video that I shot, not even with this in mind. I've shot this a year ago when we didn't even think that this technique was possible. But I gave it to our digital image correlation team, and I just said, right, okay, you telling me you can do this? Prove it. Demonstrate it to me. I don't want to go ahead and tell Network Rail we can do this work unless you can show me, because otherwise it's very risky. And the trace at the top, and these are guys who don't know anything about overhead line. They're not railway engineers. They don't know how overhead line behaves. So I didn't tell them anything. I didn't tell them what the uplift should be, what a sensible trace would look like. But the trace on the top is extremely credible. It shows the first pantograph coming through, and you can see a displacement goes up to about 43mm. And it's a 2-pantograph train, so you can then see the second pantograph coming through around about the 10-second mark. So that really gave us the confidence to say, right, we can do this. If we can do this with an ordinary SLR bit of video that frankly wasn't shot off a bridge that was itself vibrating as the train went through. So we've got teams out on site right now, and they'll be out on site over the next 3-4 months, visiting a variety of sites around the UK, gathering lots of data. And then the really interesting part is then analysing that and saying what are the actual relationships, and therefore what should designers be using when they design OLE through bridges. And we're hopeful certainly at slower speeds, but possibly at higher, if we have higher tensions as well, we might be able to reduce the uplift, which might in turn for instance mean, well, why don't we use a higher tension OLE wire run through the bridge in order to reduce the uplift, for instance. It allows us to do clever things in the design, to nibble away at those millimeters. As I say, 20mm, 30mm can be the difference between a rebuild and no rebuild.
Absolutely, yeah. There's not enough sciencey bits going into engineering. And so that for me, the more the merrier. The more that we
Yeah.
actually do some sciencey bit and then reincorporate that into engineering, the better. Because
Yeah.
it's certainly in quite a few things, definitely related to permanent way design. We've been relying on rules that haven't changed for a very, very long time, and we haven't explored the science behind those rules.
Mhm.
And actually, for all sorts of reasons, those rules might be not perhaps wrong, but not necessarily as applicable as we think, shall we say? So yeah, it's good to re-explore
absolutely.
these things.
And I mean, that's one piece of work we're involved with. There is another piece of work we're going to be involved with, which I can't talk about because we're not in contract yet. But it's Network Rail has got a whole portfolio of these work streams going on. Some of which we're involved with, some of which we aren't. Another one which we're not involved with, but we are keeping a close eye on because it's really exciting and it looks like it's going to be positive, is insulated horns on the pantograph. If you look at the image there, the extremities of the pantograph are called the horns, and they are there to manage the wire when it goes where it shouldn't go, broadly speaking. They're there to reduce the risk of the wire getting underneath the pantograph. Which is a very, very bad thing when that happens. And at the moment, all of the pantographs in the UK have metal horns. They're metal, they're live, so they have to be treated as a live part, which means when we're looking at things like public safety at stations, that's the bit of the live equipment that gets closest to passengers. So demonstrating that you can safely electrify a station can be a really challenging thing to do. If we could convert those horns to being in an insulating material, they're no longer live. And at that point, your live envelope gets smaller, and therefore the hazardous equipment moves further away from the public. So again, Network Rail and RSSB have been doing some work on that. They will be entering trials soon, so there will be a couple of trains running around on the network with these horns. They're a straight retrofit, so they're very easy to fit to the existing pantographs. And if those trials, and trials are trials, they may or may not be successful, but if they are, that again, if you're looking at arch structures, often the pantograph horn is the thing that gets closest to the bridge, and therefore it's actually that drives your electrical clearance, and that's when you get into discussing track lowers and track slews to move the pan horns away from the bridge. So, and again, this is really, it's one of those things where every little helps. If each of these initiatives could contribute 30-40 millimeters, then collectively they begin to make a really big difference to those route clearance costs can typically be 1/3 of the entire electrification cost. So if we can reduce route clearance costs, that's a huge win.
It's an interesting one, isn't it? Because for me, I get frustrated. I get a little bit frustrated. These efforts are all good, and the science certainly is. But this is where the lack of joined-up thinking becomes a problem, because fighting a huge amount, like for a business case for electrification, it's really important to fight for this stuff. But when you then look at the bigger picture and think that we ought to be striving for W12 clearance everywhere where there is electrification, so that the freight can run, it's an interesting one, isn't it? Because this helps undermine that, which is good for electrification's case, but bad for the overall railway system, arguably. So 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 there's some interesting. This is the impact that you have on a railway system overall of having certain cost pressures being king rather than the bigger picture. But anyway, Gary, you don't have to talk about that. It's fine. We have had some interesting points being made. So David Shepherd was asking about has there been any evolution in pantograph or OLE design to reduce damage to OLE from trains? Well, to an extent, you've covered that a bit there, I think.
Yeah, I mean, I think and I'm by no means a pantograph expert, and I don't represent pantograph manufacturers, but it's obviously a crucial interface that we need to understand. And I think, to their credit, the pantograph manufacturers have done a lot of work in recent years. That if you look at the HSA pantograph, for instance, which was kind of the one everyone calls the high-speed pantograph. It's a good pantograph design, but it has been completely eclipsed by the more recent pantograph designs, the HSP and the HSX, which are far more compliant, have far lower unsprung mass. And for instance, I mean, some of you will be aware that the work we did at Steventon and managed to demonstrate that what were a set of gradients that the rules told us should not work, did work and were perfectly safe and reliable to run at 110 miles an hour. I think a lot of that was to do with the design of the pantograph and the design of the overhead line. So you had high tension overhead line designed for 140 miles an hour, interacting with a very modern low unsprung mass pantograph. And I think, you know, that's a lot of the reason why we were able to get Stevenson to work. Running 2 HSA pantographs through that bridge at 110 miles an hour is probably not something I would have necessarily wanted to be around. I don't think we would have seen such favourable results there from that.
Yeah, I can understand your euphemism there. Right, okay, we've only got. I mean, Garry, I don't know how long you can overrun here.
I'm okay. I'll
right.
probably be chucked out of the office around about 8:30 or so.
Hopefully we don't go that long.
Fine.
A lot of people here are banging the table hoping it goes on and on. We've had loads of questions, lots of people enjoying. We've got 125 people watching live, which is quite a large lecture room worth of people. Hello to all of the people out there. Thanks for joining. As an interesting aside, Chris Grayling is supporting me on Patreon now, so thanks, Chris. Welcome. So this is probably a really good rail natter for you to be watching. Thanks to whoever named themselves Chris Grayling in my Patreon. That did cheer me up. Anyway, right, we're going to go down here. We're going to talk about Project Fizzy Knitting. Project Fizzy Knitting. So
yeah,
tell us
I
about
got a
Project
question
Fizzy
actually
Knitting.
for you. Did you coin Fizzy Knitting?
I
think it might be yours.
I did a Twitter search to see who had come up with Fizzy Knitting. It has been used sort of loosely by other people.
Oh, okay.
But I used Fizzy Knitting in one of my Railways Unscienced images, and I think it made you angry, and it may well have stuck.
Well, you know, I've gone through the 7 stages of grief now, and I've gone from anger to acceptance, and now I've stolen it. So, you know, yeah. Anyway, what is Project Fizzy Knitting? Like many people, I, you know, lockdown's been a difficult time. I mean, I know that lots and lots of people have had it far worse than I have. You know, I have the privilege of owning my own home and you know, having a garden and having a space which you see here that I can just commandeer during the day. So I'm not downplaying other people's real problems, but from a mental health perspective, lockdown, you know, was as bad, you know, was not great for me in the same way it hasn't been for a lot of people, I think.
Yeah.
So
Same,
as I always do when I'm not particularly happy, I find something to do. I find a project. It's quite strange actually when you look at all of my projects. You can pretty much link them to all of the down times in my life, or all of the times when I've been a bit. For instance, the Railways Archive just happened to coincide with Claire falling pregnant with my daughter. Imminent fatherhood is something that is you need to be distracted from. It's brilliant, but before you do it, you don't know. So every time I need a mental pickup, I'm always looking for something to distract. So one of the things that I've always loved maps. As a kid, I remember sitting and reading, you know, I had an atlas of the UK and a world atlas, and I used to read them like other people read fiction. You know, I used to just pore over them. So it's always frustrated me a little bit that we didn't have a really good electrification map of the UK. We have, you know, obviously people will be aware of the paper maps that are available there. I've got a couple here. They've got the OPC atlas and track maps and all those good things, but none of them really give you a really good detailed view of what's electrified and what isn't. And obviously with the decarbonisation debate now really well underway, it felt like a good time to create that map and make it available to people so that, you know, we could inform the debate a little bit and actually see graphically how much of the network isn't electrified. So that was the kind of thing that I had in my head. How could we do that? What I didn't want to do though was draw a map, right? I mean, anybody who's done any cartography knows, you know, this needed to be a quick and dirty project rather than something that would occupy years of my life. I already have other projects that have occupied years of my life, and the last thing I needed was another one. So it's how do we create a map without actually having to create a map? Well, luckily we have this wonderful asset called the OpenStreetMap, which people may or may not be aware of, but it's an open source map. It's a map it's a community created map. It's like Wikipedia for mapping. And I mean, it's quite an extraordinary project, really. And I previously have dabbled with it. A few years ago, I mapped our village where I live, and I mapped my old neighborhood where I grew up. And you can ride a bike around your neighborhood with a GPS and record a load of traces, and then turn that into a bit of mapping. So the OpenStreetMap exists already, and it's a map of the world.
Yeah, I thought I'd bring it up.
Yeah,
and
so there it is. There's the whole thing, and this isn't Google Maps. This isn't a proprietary mapping system. This is open source, free to reuse, free to repurpose. And so, I started thinking, I wonder if what's the rail mapping like within OpenStreetMap, and I'm going to be slightly cautious here because it's not perfect, and certainly as we've done this project, we've discovered where its imperfections lie. It's not perfect, and when our map eventually goes public, there'll be some very stiff health warnings on it. There'll be some do not use this map for safety critical work. Do not trust this map. Do not assume it's 100% correct because it isn't, and it never can be, because it's user editable. Anybody can create. Its greatest strength is also its greatest weakness. Anybody can edit it. You can literally register with an OpenStreetMap account, and you can be editing this map within about 20 minutes. It's very, very easy. It's got a very low, very shallow learning curve to edit the map, and that's brilliant, but also potentially quite dangerous. So we're being quite careful about exactly what level of detail we provide, and how we tell people about how to use this map. But the idea is to leverage the railway data that's already there. The routes are mapped, the tracks are mapped. Some of the things like depots and sidings tend to be a bit hit and miss, but it's generally pretty good data. So the idea was to leverage that to clean up the electrification tagging, the electrification metadata within the OpenStreetMap database, and then to create a map which pulls that electrification view forward and fades the other stuff into the background. So that's what we've done. And
indeed, and here is what it looks like in full screen mode with the fade to black bit, which you said is like a work in progress actually. Yeah. But I quite like it because it shows the fizzy bits very, very nicely. Yeah. There it is. So we've got it up exclusively for RailNatter. This is the map.
This is a world exclusive.
So let's zoom in on.
We're not quite ready, and Gareth's got the URL, and he's sworn blind he won't give it to anybody else.
No one gets this. Don't worry.
It's still. We've still, at the moment, the site's a prototype. It's not a nice, shiny, polished website. There's still some issues with symbology and line styles, and we've got a few. I'm still getting my head around some of the voltages on the third rail network, for instance. So there's a few things to do, but we're not far away now. We're pretty happy with the electrification data that's in OpenStreetMap. We've even had to negotiate with OpenStreetMap to change some of their tagging to.
Oh wow!
So, for instance, they didn't have an agreed way of tagging dual voltage areas, and they didn't have anything for fourth rail. In fact, when we discussed it with the community, because it's an open source community, and you know what open source communities can be like, they can be quite. They can be quite robust. They've been doing this for years, and who the hell are you to come along and start trying to mess up our tagging structure? But to be fair, we went through their process. There's a voting process. You have to put a proposal forward, and then it gets voted on. And we got the changes to tagging structure agreed. So now we've got a tag for fourth rail. We've got an agreed way of dealing with dual voltage areas, which means that we can then color code those areas as we want to. So broadly speaking, on this map, AC electrification, the 25 kV is in red. Other overhead line is in various shades of red, orange. The third rail network is in various shades of green, depending on voltage, and the fourth rail network is in various shades of blue, depending on voltage. And then the dual voltage areas are alarming shades of pink and purple.
Yes.
Kind of, it takes a lot. It's easy to kind of say, just color code it differently, but just agreeing color coding it's difficult to be sort of systematic about what those colors mean. But I think we've come to a good conclusion now. And we've got a good color coding structure. And also you can see the great thing about OpenStreetMap is it's not just the existing railways. The railways under construction are already in there. So East West Rail has got a trace. Crossrail's got a trace. It's all in there. And even High Speed 2 that you can see the dashed line there is already, and that's not, we haven't put it in there. It's already in there.
Also, I see West Midlands Metro has even got its
so somebody has
incorrectly named metro system there.
Potential extension of West Midland Metro. So this isn't, this is a scheme that may go ahead in the future. So I think in terms of giving an overall, the more we've done this, the more I've realised that this map, there's nothing else like this at the moment for the UK. There's a project called Open Rail Map, which is doing something similar for the whole of Europe, but it's not looking at electrification. It doesn't surface the electrification data specifically. So yeah, it's the more we've worked on it, the more we've thought, well, this is quite useful as an overview, but only as an overview. It's not. There are going to be errors if you. I mean, what's that? Leeds? Is that?
That's Neville Hill. Yeah.
That's Neville Hill. Yeah. So is every siding exactly correctly shown there? Is it millimeter accurate? Absolutely not, and you should not be using this data for that. And that's why, for instance, we've limited the zoom level. We've deliberately, that's as far as you can zoom in. Yeah. We're not letting you go all the way in.
I'd be getting very angry if this was the true track alignment through here.
Oh yeah, the alignments are shocking. Yeah. I mean, obviously on running lines, what people are generally doing is they're getting on a train, or they were getting on a train,
GPS trace,
recording the GPS trace, but you can't do that in a siding. So yeah, some of the siding layouts that I've got to have been an unholy mess, and we've done a little bit of work to box them into approximate shape, but they're never going to be accurate, and that's not the purpose of this map. It's to allow people who are interested in the electrification agenda to see what is wired, what isn't wired, and help them discuss and debate what should be wired, and that sort of thing.
Yeah, it's brilliant. It's absolutely fantastic.
I should add, it will show. If you were to switch back away from this full screen mode, you'll also see all the non-electrified lines in black. No, I
don't want to do that.
So you have got the whole. Was that the URL? Right.
It might have been. That's fine. Go on there.
We'll blur that before it goes on YouTube. Don't worry. We do also show the non-electric. You can see the whole picture. And what it really, if you zoom out to the national level, it really just shows you.
Oh, it's gone. I've got rid of that now because I'll have to URL it. But anyway, I think people had a good overview of what that will eventually look like. And actually, if we go back to get the slides out, so this was my map showing. Look, there's a map, but nothing on it really because there's not a good electrification map. You're going to kind of show some of these stats, I think, on the website.
Yeah,
right?
We're going to put alongside that on the website just to give a numerical view of what the map shows you graphically, is just to present a snapshot of the current state of play. And these are my numbers. They aren't official numbers, but I have cross-checked them against the Network Rail overall numbers, so they're a good match for the official statistics. And it really shows the state of play, and it shows how much there is to do at the moment. And this is measured by there's two ways of measuring electrification. There's route kilometres and single track kilometres. So route kilometres is, if Swindon to Reading is 30 miles, that's 30 route miles, or 30 times 1.6 route kilometres. But it's a 4-track railway, so therefore it's 30 times 4 STKs. That's the way that you do the maths. We always use STKs because it's a more accurate picture of how much work is involved.
Yes.
Clearly, electrifying a 4-track railway is significantly more work than electrifying a 2-track railway.
I like STKs because you can compare. It's easier to compare general infrastructure project costs as well. So I prefer STKs. Yeah,
it's Signalling have their kind of single unit of signalling, don't they? It's our unit of cost really that we use. So as you can see, less than half the network is currently electrified, measured by STK. I mean, if you measure it by train miles, it's, most train miles are electric train miles, but if you look at network, it's less than 50%.
Yeah, right, okay. Conscious of it being 8:05. Thanks everyone for sticking with us. And apologies for people who are on audio and can't see this. This is a pie chart showing the difference between, the different percentages between. So yeah, non-electrified, 53.5% of the network, and then the rest is 32% of the overall is standard OLE, and then the rest is split between third and fourth rail. The next bit is just the key, really, to your. So I think you were describing that earlier. We don't need to really dwell on it. That's just the key.
We spent quite a lot of time getting this right, really, and getting the symbology right, so that there would be some, so that the colour carries meaning, and also that the dashes carry meaning. So, and as you can see, there's a couple of TBCs there, because I'm still trying to work out some of the details on the voltages on the third rail. And when I understand that fully, then we'll be able to decide what shade of green to use. So yeah.
So we've got some questions. Well, we've got one question which I think maybe you're going to cover, or at least there'll be a useful picture for it briefly. So I'm going to hold back from David. Anyway, lots of good chat. Thanks everyone for joining and chatting. It always helps. The OLEbook. For those who don't know, Garry. Oh wait a minute. I can do this. I can do a Blue Peter moment with this. Look at this thing. Hooray! Let me go side by side so it's bigger. It's the OLEbook. #OLEbook with by Garry. It's very good. You can literally now go and download this for free.
Yep.
And in fact, Garry and I would both recommend you to do that. You don't have to pay for the hard copy. There is a free PDF one. It so happens to be that a lot of people really wanted a hard copy, more than you'd planned or thought.
A surprisingly foolish number of people who were willing to part with their hard-earned money. Now that was an amazing thing that happened last year. Really kind of took me by surprise, really. So and so where are we with that? So my original plan, lots of people had plans this year, didn't they? Which have come to nothing. My original plan was to do another print run in the spring, just gone, in March, in March and April. But clearly the world changed in March and April, and at that point there was so much uncertainty. Uncertainty in my personal life, uncertainty at work, uncertainty, lots of people not knowing, even whether they had a job the next month. So we decided that we weren't going to go ahead with the print run in March, April. Since then, I've kind of been, maybe once a month or so saying, okay, how do we feel about things now? The sense I get at the moment, it's very difficult because, as anybody involved in marketing will tell you, it's very difficult to understand what your customers and your audience really wants. You can conduct polls and things, but most people don't respond to polls. The sense I get at the moment is there's some people who have been largely, economically at least, largely unaffected by COVID-19. I'm one of those people. I'm very lucky in that respect, but I'm very conscious that there are at least as many people who have been significantly impacted. People in our industry have been put on furlough. People even who have lost their jobs. So at the moment it just didn't fit. It still doesn't feel right to do a print run, because there'll be people out there who would want a book but wouldn't want to buy one now, and would feel, and I don't want to. I last thing I want to do is add to anybody's mental health problems this year. So in terms of, should I buy, should I not buy, can I afford it, all of that stuff. So I think for the moment what we're going to do is we're not going to do a print run this year. And I think the reality is what we're probably going to just do is focus on. So you've got the 5th edition. The 5th edition is the one you're holding up. That's the one that's available on the website. There is a 6th edition. It's a draft. It's a work in progress. I was doing quite well with it, and then lockdown pretty much ruined my ability to do any long-term thinking and planning for a while. So I just stopped. Like lots of people, I just stopped what I was doing and focused on the here and now, focused on the day job, really. So I think as we get into the autumn and I get the Fizzy knitting thing out of the way, I will get back on to doing. I've already drafted quite a few new sections, upgraded quite a few sections, but I've still got probably 50% of the way through the drafting process for the 6th edition. So in terms of timeline, my aim would be probably to issue 6th edition online back end of next year, so towards the end of 2021, and then either go for a print edition just before, shortly before Christmas 21 or in spring 22. I don't think I wouldn't feel right trying to flog the 5th edition next spring, well, maybe hopefully, fingers crossed, things have improved, when I know that the 6th edition is just around the corner. That wouldn't feel right. So yeah, so for those of you who are desperate for a print 5th edition, I apologise. And for those of you who are happy to wait, then some fresh content is on its way. It's something you should be very proud of, Gary. You've got several projects that you created that you should be very proud of. I think the Railways Archive is an absolutely sensational bit of kit. A lot of us use it; it's invaluable. But the OLEbook is terrific. I refer to it quite regularly, and in fact, I'm giving a seminar about electrification. Don't laugh; it's a strategic level, so it's fine. I don't have to know anything really about electrification. But I will have this thing down underneath me just in case the Colombians ask me any tricky questions. Sure. So it's fantastic. I'd recommend everyone to download it. One really important thing that I don't say enough actually is that it wasn't a sole effort. I could not have written that book without, first of all, the knowledge that I've gained from other people who are better at electrification than me. So many people, I'm constantly asking other people questions and then rewording what they tell me. Putting that in my own words, but also the number of people who check individual sections for me, particularly for the 6th edition. I'm in areas where I am wildly incompetent. So I've written a section on how railway traction works. I've written a section on how electric locomotives work. Yeah, exactly. And
brave. Oh, and we've got that I can do. Let's go side by side because
that's been a learning journey for me. Look at this. Yeah. So that's a couple of the diagrams that are going to be in the 6th edition. Neither of these have been checked, by the way, so I will reserve the right to change these. These are pre-IDC in railway parlance. But just understanding how electric trains work, and particularly how modern traction works, is not something I'm remotely experienced in. I sit on the other side of that interface. But it's surprising how few people in my job don't understand how railway traction works. So I felt for the 6th edition it was really important to reach across that divide. So one of my tasks as we go into autumn is to find somebody who has got the relevant experience and competence who can check what I've written. And I've got a few ideas about that. I'm very lucky in being quite well connected these days. So luckily I have people within the rolling stock community who are experts on this, who will no doubt tear my words to pieces and make them work. So I'm moving into areas outside my competence, but that hopefully to bring them inside and it helps me to learn as well, because I have a very low boredom threshold. If I'm not learning something, then I get bored, and once I get bored, I'm dangerous. You don't want me being bored because I switch off. So this keeps me sharp. It's always good.
Both of us are guilty of having too many of spinning far too many plates at any given moment. Yeah. It's not good. But also, it's, as you say, it's because these things keep us entertained and it feels like you're doing something. Anyway, right? Yeah, that's great. Thanks for that update. Oh yeah, so these are quite. Sorry for everyone on YouTube, because even on YouTube these are quite fine images. So we're going to shout at Gary for that.
Yeah, they don't translate brilliantly, do they?
But tell us about this. So why were you?
Yeah, I thought this would excite you because it's track.
It is track. There's some S&C, some squished S&C.
Well, yeah. So I've been trying to understand about it, and again, this is learning for me. Over at Line Engineers, generally we get away in the UK anyway. We tend to get away with not having to understand S&C geometry because we adhere to a fairly simple play school set of rules about how to lay out the wiring geometry at turnouts. And a couple of years ago I thought, well, this isn't good enough. We should. And then I started reading another book, a very good but quite challenging book, the Siemens over a Line book, which explains the European way of doing turnouts. And they're not They don't afraid. They don't pussyfoot around like us in the UK. They get stuck in to turnout geometry. So I expanded the turnout section chiefly to try and understand how the hell it is that they do it and what it is that they do. So yeah, I got last year I got very bogged down in stretched S&C diagrams like this and trying to understand how it all works. I'm still not sure I entirely understand how it works, but I've had a go anyway. You can judge for yourselves when you read the 6th edition.
Which leads to David Shepherd's question, which is about the how tricky is it to wire up S&C? So S&C switches and crossings where tracks intersect. How tricky is it? Is it really tricky, or is it?
What we do is, I mean, this is a really wonderful diagram, because we do, OLE engineers, we're guilty of this all the time. If you open any of the system manuals, so all of our OLE systems now come with a manual. And they tell you how to. They give you the rules, the set out rules. They tell you how to wire things, what you're allowed to do, what you're not allowed to do. And whenever you get to the turnout geometry section, there's always a diagram like this that shows you how to wire a crossover, and it's always a crossover with a standard 6-foot tangent track, no bridges or stations or level crossings or buildings or anything else, and no constraints. They're completely unconstrained, and to wire a crossover that's unconstrained is very easy. You just follow the rules broadly, and the rules are fairly straightforward as well. But of course, the real railway is not like that, and it is difficult with the OLE manuals because they describe a railway that doesn't exist very often. It does exist sometimes, on open route sections, but a lot of the time, the skill that the people that I work with, the people in Atkins and in other design houses, the skill that they add, you might think, well, they're just applying the rules and rolling out the giant Meccano set. No, there's a lot more to it than that, because they have to take all of these rules and then apply them to a scenario where they can't meet all the rules. You often can't meet all of the rules that are in the manuals.
There are almost no situations where you can apply the rules without needing to apply judgment to it.
Yeah.
That's why we get paid the moderately okay bucks, because the fact is that you can't just computer apply the standards. It doesn't
a really
work.
good example of this is a location near me, Huntsmill Road, just outside Swindon, where that control structure is on the turnout opening is under a bridge, and there's no room to get a structure. So you've got to control exactly that there. You've got to control the wiring at that point, but there's a bridge there. So what are you going to do? You're going to hang the control structure off the bridge? Are you going to demolish the bridge? Are you going to, what are you going to do? And those are the situations. Those are where my colleagues, that's where they earn their money. That's where they earn their money.
That's the fun stuff. That's the stuff that keeps us entertained, Gary, isn't it?
We'll come to you and go. We'll come to you and say, move that crossover. Just move it.
Yeah, and then I'll flip
because I can't. And then you'll start reeling off all of the rules and constraints that you've got to apply in your discipline, which means that you can't move it. And then the civil engineer will chip in and say, well, I can't possibly rebuild the bridge because there's a row of houses next to it. So,
and then the signallers will come along and say, yeah, but you're that distance from that other junction and our overlap, and we're double blocking, or there's some, the overlaps mean you have to move the crossover by another 32 metres in the down direction. And then
that's why
your hair catches
That's why
fire.
Railway engineers always say the pain is at the interfaces.
Yeah.
Designing within your discipline is the easy bit of the job. The hard bit of the job is delivering a design that works with all the other railway systems.
I think that broadly. What time is it? It's 2018. This isn't the most catastrophically long-running rail natter. It was always going to be a long one. So, send any questions that I've missed. Anything you want to ask, Gary? Given the subject matter we've covered, go for it. People are asking me confusing questions like, can you very quickly explain what reduced phantom overlap is? No, I cannot.
A what?
A reduced phantom overlap. I think it might be a fiction. It might be fiction. Don't worry about it. Roman Adocrat's trolling us. That's fine. People are saying this is why Crossrail isn't open yet, referring to the interfaces. Yes, that's correct. Although lots of signalling interfaces with themselves in lots of cases. Let's not worry too much about that. We were asked a question earlier about how tricky is it to wire up in N gauge. That's one for you, Gary.
Well, it's funny because I do have a little bit of N gauge stuff.
Really?
That I occasionally get out and play with. My eyesight, I'm 49, and my eyesight is absolutely shocking. I'm now reduced to wearing these when I want, even if I want to read something. So for me personally, absolutely no chance. For the sort of bit at the other end of scale, you can go on YouTube and see people building RC cars in 150th scale. So anything's possible, but I wouldn't. I see people do it in 00 gauge, and some people achieve mind-blowing results. I don't know how they do it. I don't know how they have the patience.
I went to the Great Central to look at a model railway thing last year, and there was some decent OLE there. I was judging them on the lack of stagger. Where the OLE goes zigzagging from one side to the other. That was disappointing.
You can't do that. It's not fair. I've done the same. I've gone to I went to a model railway exhibition 2-3 years ago in our village, and there was an incredible Swiss layout, and it was like a layer cake. It was tiered up through the mountains, and it was beautiful. It was a work of art, and this retired chap, had, it was his life's work. It was brilliant, and was the overhead line perfect on it? Of course it wasn't.
Did you drag him over it? Of course you did.
I did absolutely not. I wouldn't have dreamt of it, because this guy was an artist, So no, it's the mere act of getting overhead line onto a model railway and on an exhibition layout as well.
Which get pretty rough and tumble.
Amazing thing to do.
My favourite very small bit of N-gauge electrification, which is actually a little bit. Tasha, if you're watching, or Charlotte, or anyone from the museum, there's a bridge arm that's fallen off the stretch of Channel Tunnel rail link from the 1970s. You need to go in and fix it. But actually, it's a really immaculate, with a nice French continental train. This is from the old 1970s channel.
The cleverest ones, actually, are the ones who you sometimes see it. They put the structures in, but not the wires.
Yeah, that's clever.
And if it's done right. If it's not done right, it looks obvious. But I've seen people do it, and you do a double take because you don't see it straight away, and that's just amazing. It's all smoke and it's all sleight of hand and smoke and mirrors. Brilliant.
At some point in the distant future, I might attempt it when I try and recreate my bit of 1980s BR whatever on a plank. Anyway, I digress horribly. David Shepherd's got another question, which is quite an interesting one, which is. I suppose we can both conject about. What are the failure options for keeping the railway open if the OLE gets damaged?
Well, the first thing to do, and I'm like a broken record with this, is not damage it. The first thing to do is to do the work, do the hard work of making overhead line reliable, because famously, unlike virtually every other railway system, there is no redundancy available in the contact wire, so you can't have a second contact wire. You can't have an emergency system that swings into action when the contact wire gets broken. And that's why we overhead line engineers drive our colleagues in other disciplines crazy by really focusing on I can't wire it like that, it won't be reliable. We all of our efforts, and sometimes it might be an obvious why we're insisting on doing it a certain way. It's always ultimately about two things: safety and reliability. Those two things are at the absolute core of what we do, because we don't have the luxury of a backup. The second thing is when it does go wrong, you need a recovery process that gets things back up and running as quickly as possible. I know where this question is kind of trying to drag us into buy modes and all of these sorts of things. I think before we go there, we understand the failure modes of overhead line relatively well. There's probably more work we could do on that. And I know that's something that Network Rail already are doing to improve their understanding of failure modes. But it's really focusing on prevention rather than cure.
Yeah, definitely. It's interesting you talk about reliability, because it's the same thing that I try and push in my day job. Is actually it takes a lot longer for OLE goes catastrophically wrong. If it goes wrong, often it goes catastrophically wrong. But P-way, it's similar. We try and design for reliability, and a lot of the stuff we do when we're trying to stick with it, trying to keep it within standard compliance, is because within those brackets, it's likely to last longer and not be as much of a problem. Yeah. So it's interesting, and there are certain things.
A good example is at the start of although we got many things wrong in CP5, as is well documented. There are things we got right in CP5, and they tend to go unnoticed because, because of the negative stuff's very distracting. At the start of CP5, Network Rail it knew it needed a new OLE system, and it identified, part of that early work, identified the famous 93 failure modes. So there were 93 failure modes in the OLEMI, in the Mark 3B overhead line system that Network Rail identified, and it then looked at every single one of those failure modes and designed virtually all of them out of the modern system. So the system that is being rolled out now is being used on Midland Main Line and will be used on future schemes is called UK Master Series, and UK Master Series is the industry's response to a modern OLE system that addresses those failure modes. So as one example, the Mark 3B registration arm, which sits on the contact wire and holds it steady, has 3 components, and they're crimped together. And the integrity of that arm depends entirely on the quality of the crimping. And the crimping's done by someone in a factory. So, quality control processes in factories can go wrong. So the UKMS arms, because there's several different types, but they all have one thing in common, which is they are a one-piece arm, one-piece extrusion. And there's 93 of those failure modes that have all been addressed. And actually, when you look at the reliability, we've got about 3 years worth of data now on Great Western, on the overhead line there, and it is performing very well. It is behaving itself. It is not suffering from any significant reliability issues.
So it
shows that it can be done.
I'm very much looking forward to comparing that to the East Coast Main Line. For me, my ultimate aim is to compare East Coast Main Line reliability, capex and opex, accounting for its reliability with GWEP, and showing that even with the expensive bits of GWEP is cheaper in the long run. That's my ultimate aim, and it might be a rail piece I have to do in 5 or 6 years when we start getting data that I can project into the future from GWEP. But I'm looking forward to doing that, because from my perspective, where I'm coming from, where money isn't an issue, human resources and time are the issue. I'd rather if we're building something closing the railway, we should be building it right and not building it cheap. Right, okay, any other questions? I think I'm going to probably wrap us up because of time, and Garry in fact, I've got, very kindly, Dina brought me some fish fingers and chips that have been sat next to me that I need to eat. There we are, that's dinner. Thanks, Dee. It's been an absolute pleasure, Garry. All I'm going to do is put us next to each other, and then the old classic hashtag electrify all the things, because that's what we need to be doing, big time.
Yes. And if you can afford it, do go and buy Noel Dolphins t-shirts.
Yeah. Yes.
Excellent.
Going to a good cause. Yes, agreed. And what are my normal sundries? Oh yeah, for everyone who joined on the podcast, do give feedback on how dreadful a job I do of audio describing the slides. I think I do a reasonably dismal job of it, so I always need to do better. Thanks, Giel, for putting those onto the various podcasting sites. Next week we have Luke, Tube Mapper, is going to be joining us, as very recently negotiated. That should be good. Talking about beauty from mundanity. Kind of creating beauty from the mundane, which is something right up my street, because I love things that are mundane, and then if you can take pictures that make them look good, that's even better. So that should be very interesting. But I'm sure there'll be all sorts of chat going on with that, so that'll be a pleasure. And the usual stuff, Patreon. Thanks, Chris Grayling, again, big shout out. So support me on Patreon. That's where you get to steer what these do and who gets to appear next. It only remains really to say, that's a nice chat, Garry. We haven't had a chat in ages, actually. The point of these is always that they're kind of affording people the chance to sit in on a pub chat, because that's a lot of information passes around that way rather than in seminar form. So that's kind of why these exist. It's quite nice. It's quite nice to have that in lockdown.
Yeah, it's been good.
Or whatever this is that we're in now. It's not lockdown. It's sort of half lockdown, right? I don't know.
We do need a name for whatever the hell this is. I don't think anyone's yet nailed it on what 2020 is. A disaster.
Yeah, maybe. Yeah, something like that. It's been great, Garry. It really has been great, and probably a million questions that haven't been answered as well. There are loads of questions in the chat, steering all over the place. There's a huge amount of detailed chat about tractive effort and traction going on as well. Love the chat. It's just chaos in there. And thanks for everyone who's stuck with us. Still got 110 people watching, which is nice. It only remains for the two of us to sort of say cheerio. Garry, don't hang up on me immediately after this, because I always forget to tell people that in the opening, in my like pre-Railnatter brief, because I say thanks when I put the credits on. Anyway, there's a little insight for everyone. Cheerio, everyone. Cheerio.
Bye bye.